one is I will calculate slopes and derivatives using the definition of the derivative, and your graph f from the graph of f prime and graph f prime from the graph of f, and graph the derivative of a function given numerically with data. So a lot going on with this section. Let's go ahead and get ourselves a pen ready to go. All right. So the definition of a derivative, the derivative function f with respect to the variable x, is a function f prime of x, whose value at x is f prime equals the limit as h approaches 0 of f of x plus h minus f of x all over h, provided the limit exists. Now, in the last chapter, we did this with a, and so we were finding the derivative at a particular value. This is going to give us the function of the derivative, or the equation for the derivative that will give us the derivative at any point, not just any one point. Differentiable functions, the domain of f prime, the set of points in the domain of f for which the limit exists, may be smaller than the domain of f. If f prime exists, we say that f has a derivative is differentiable at x. A function that is differentiable at every point in its domain is a differentiable function. So that's the biggest thing, is if it's differentiable at every point. So we are going to talk about later ones that are not differentiable. So definition of derivative, differentiate fx at x squared. So this one is f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over it's just h all over h. So that just means here that every word on this one, every time we see an x, we're going to put an x plus h and then minus this value. So anyways, f prime of x is equal to the limit as h approaches 0 of x plus h squared minus x squared all over h. Now, this is one of those algebra 1 skill, so I'm going to just write it over here, side work, instead of just saying, oh, this is what we're going to do, this is how we're going to get there. X plus h squared, that's actually x plus h quantity squared, because it's the quantity of what's in there, or x plus h times x plus h. And then we FOIL, distribute, whatever you want to call it. X times x gives us x squared. X times h gives us plus xh. X times h again plus xh. And then h times h gives us h squared. Combine like terms here, and we have x squared plus 2xh plus h squared. If you do enough of these problems that has x squared in it, you'll get used to what the value is. So now we have x squared plus 2xh plus h squared minus x squared all over h. Anything that does not have this is a good check. Anything that doesn't have an h on it should cancel out. And here we have a positive and negative x squared, and everything else has an h left on it. So we're going to go ahead and factor the h out on top. So we have an h times 2x plus h all over h. Cancel these out, and we're left with this. So now we can do the limit as h approaches 0, and this gives us a value of 2x. So f prime of x is equal to 2x. And anywhere on our function of x squared, we can find now the instantaneous rate of change or slope of the function. All right, let's try another one. You try a definition, here you go, fx cubed. Still the same idea. We're doing the limit as h approaches 0 of f of x plus h minus f of x all over h. So now we have f prime of x equals the limit as h approaches 0 of x plus h cubed minus x cubed all over h. So here's my side work again. Now this is one that we've done before, Pascal's triangle. This is power of 0. 2 ones is power of 1. 1, 2, 1 is a power of 2. All right, and then we have the power 2, which is a problem we just did the last time. And if you notice, the coefficients on the front were 1 and 1, and the one in the middle was 2. And then for power 3, it would be 1. 1 plus 2 is 3. 2 plus 1 is 3. And then 1. This will give us a power of 3. So this is going to work on each power as you go. What you need to do is you'll just have to continue on or have this memorized. There's also another way of doing it using combinations. And so if you're only having 1 through 4, it's just as easy to write this up together. So in that case, then we have, when I expand this out, because now it's x plus h times x plus h times x plus h. Well, we really don't want to have to multiply this out and then multiply this guy as well. So I'm going to use these coefficients. So it's going to be 1, 2 sets of parentheses, plus 3, 2 sets of parentheses, plus 3 again, plus 1 and 2 sets of parentheses. I'm going to try and squeeze that in there. And in the first parentheses, you're going to put in x, 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 x. The second parentheses, you put in h, 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 and h. I'm going to grab just a different color to do the powers in. That way they don't get so lost in here. Now, the powers on each of these have to add up to the whatever power you're working on, in this case, 3. The first one will get 3, and that means this guy is 0. And then you go down by 1. So this is 2, so h gets 1. Go down by 1, so this is 1, that means h gets 2. And go down by 1, 0, and h gets 3. So in the end, we have x cubed plus 3x squared h plus 3xh squared plus h cubed. Now, for those of you who have forgotten, anything to the 0 power is 1 except for 0. 0 to the 0 power is still 0. But 1 to the 0 power or 5 to the 0 power is 1. That's why this guy was, no, this guy just went to 1. So now we have here the limit as h approaches 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed minus our original function, x cubed, all over h. Anything without an h to cancel out. There's my positive x cubed, there's my negative x cubed. Everything else has an h in it. So I'm going to go ahead and factor it out. So h times, this is going to be left with 3x squared plus this one here, one of the h's got out, so it's 3xh plus, and then 3 minus 1 gives me h squared all over h. H's cancel out, and we're left with this. Now I can plug in 0, and this guy goes to 0, this guy goes to 0. I'm only left with 3x squared. So f prime of x, in this case, will be 3x squared. And there you guys have it on that one. So even though I showed you on this one here, again, you could have just multiplied this out and then because we had this on the last problem, so you could have just multiplied by x plus h. Things to watch for, things to know. Okay, so I give you another one. This time I threw it in a fraction form, but we're still doing, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So in this one, f prime of x equals the limit as h approaches 0 of 1 over x plus h minus 1 over x all over h. Yes, we're going to do some side work here in a little bit again. Now, this one here, we just need a common denominator, but don't fall into that loophole of, oh, I just need a plus h over here. You cannot add, you can only multiply to get a new denominator. So since I don't have the plus h on this guy, I'm going to grab another pen so we can see things being changed a little bit. I'm going to multiply top and bottom here by x plus h. And on this one, I'm going to multiply top and bottom by x. Now, some of you know the way I will do what I call cake boxing, is I multiply 1 times x, multiply by x, and then I multiply this way. And then I multiply the denominator. You're going to get the same answer in the end. So this one, limit as h approaches 0, I have x minus the x plus h all over x times x plus h all over h. A little bit of cleanup to do on this one. So if I distribute the negative through on that, so now I have the limit as h approaches 0 of x minus h over, now that I have this common denominator, I can bring this guy up into the denominator where he belongs. So it's going to be h x times x plus h. Now, I'm going to do the side work for this one here, so just point over here, the side work. Because some students just don't see this, and it's all right. So on this one here, I have the x minus x plus negative h all over x times x plus h all over, and I'm going to write it as h over 1. Well, this is just this fraction, which, by the way, this is going to cancel out. This fraction divided by this fraction. We all know how to divide fractions. You take the first one, and then you multiply by the reciprocal of the second one, 1 over h. And this is where we get to cancel out our h's, but you can see that the h ended up going into the denominator. So this one here, I said it was going to be negative h over hx, x plus h. Those cancel out, but please be aware there is still a 1 up there. You don't cancel everything out and then it just disappears. So the limit as h approaches 0 of negative 1 over x times x plus h. So this guy goes to 0, and we're left with negative 1 over x squared. So in this case, f prime of x is equal to negative 1 over x squared. Right, so and this is the difference quotient for those of you going, oh, aren't we just, yes, you're just using the difference quotient. And you'll see that this one being used a lot, especially in the first couple sections of the chapter. Once we get into section 3, we'll really get into the rules of derivatives. So derivative at alternate point, we did this in section 2.3, 2.4, not sure which one we did it in. the derivative of function f at a point where x equals a is the limit f of x minus f of a over x minus a, where the limit as x approaches a. So this is going to help a little bit more because we're actually putting a value in for our function. What you're going to do is you're going to get the derivative at that value rather than the function, the actual derivative itself by itself. So this is just going to give you the derivative value. So let's apply the alternate. So now remember the alternate is, I'm trying to decide where to write it, f prime of x is equal to the limit as x approaches a of f of x minus f of a all over x minus a. So this time you're going to leave the function, so square root of x, limit as x approaches a of the square root of x minus the square root of a all over x minus a. Now, if I plugged a in, I'm going to get 0 over 0. And this is going to be usually the case on these. So we have to do a little bit more math. Now, this is one where we're going to rationalize the numerator. So I'm trying to grab a different pen so you guys can see. Rationalizing the numerator just means take this guy but change the middle number to plus instead of minus. So I'm going to get square root of x plus square root of a over the square root of x plus the square root of a. This is where my side work is going to come in handy. I lost my cursor. There it is. This is where the side work is going to come in really, really handy because this is work that we need to do, but you don't necessarily need to show it within the problem. So I have the square root of x minus the square root of a times the square root of x plus, that's x, plus the square root of a. And this is one, it's a difference of squares, so after a while you should be able to recognize this, but I would go ahead and go through with it. But before I do, I'm going to actually write down the answer over here. When I multiply this out, I'm simply going to get x minus a on top. Because when I FOIL this, I get square root of x times square root of x, or the square root of x squared. Multiply the x and a, and I get plus square root of ax. But this time when I multiply, I have a negative, so it's negative square root of ax. And I multiply these two together, I get negative square root of a squared. There's a couple of things are going on here right now. This right here, opposites, so they disappear, they cancel out. And the square root of x squared, radical cancels a square, is left with just x. And then minus, same thing here, radical cancels a square, and I'm only left with a. But this is a difference of squares. This will work every single time you multiply by the conjugate. The conjugate is this guy rewritten with the opposite sign in between. So now I have x minus a over x minus a times square root of x plus square root of a. These two guys are going to cancel out. Don't forget you have a times 1 on top. So now I'm left with the limit as x approaches a of 1 over square root of x plus square root of a. Now I can plug that a into x. So I have 1 over square root of a plus square root of a, which gives me 1 over 2 square root of a. So this is not f prime of x, this is f prime of a. So this is still the same thing. I know you guys are going, it's still a variable. Well, we couldn't throw x in there a second time. That's the point that's trying to be made. I had to use a second variable. But I could have thrown a number in there and say the number was 2. Now I'd have 1 over 4. Okay, I lied. Let's say it was 4. Then I would have 1 over 4. Okay, so this one here. Now notice that they are giving us an actual number for a. So the limit as x approaches 2 of f of x minus f of a over x minus a. So I have the limit as x approaches 2 of 1 over x minus 1 over 2 all over x minus 2. And here we have that fraction thing going on again. But I just need to get a common denominator. So when I get a common denominator here, I'm actually get a different color as we write it out. If I multiply this way, 1 times 2 is 2 minus, and then I multiply this way, I get x over, and I multiply this way. This is what I call the kickboxing. 2x all over x minus 2. Now hopefully you remembered what I showed you guys before. Now that I have the common denominator here, I can bring this whole guy up where he belongs into the denominator. So now I have the limit as x approaches 2 of 2 minus x over 2x times x minus 2. Okay, I can hear my friends saying, you need to show the step. You need to show the step. All right, fine. Here's the step. I have 2 minus x over 2x divided by x minus 2. And we can make it over 1 so that we have a fraction, right? There's the numerator divided by x minus 2. So 2 minus x over 2x times the reciprocal, and we get back to this over here. Now, what I need to make sure that you're paying attention to, because if I throw 2 in still, I'm going to get 0 over 0. So we have to still do a little bit of math, and it's going to be on these guys here. So if I have 2 minus x, and I factor out a -1, -1 times what's going to get me back to 2? Well, it's going to be -2. And -1 times what's going to get me back to -x, just a positive x. Anyways, you factor out a -1, and you can flip the order of your positive negatives here. So I now have the limit as x approaches 2 of -1 times x minus 2 over 2x times x minus 2. And these two lovelies get to cancel out, and we're left with -1 over 2x. But it's the limit as x approaches 2. So f prime at 2 is equal to -1 over 4. Did not put there. So that function there, the derivative value at 2 is -1/4. I was looking, the video is getting kind of long, so I need to cut this one off here in a minute. I think this is the last one I wanted to try. If not, this is where I would cut it off. It's just one more of these, a little bit different, that we're still doing the limit as x approaches 1, f of x minus f of a over x minus a. So we have the limit as x approaches, sorry, that should really be a there, approaches 1 of x squared plus 4 minus 1 squared plus 4 over x minus 1. So we go through, limit as x approaches 1, clean this up, I have x squared plus 4 minus, and this is 1 plus 4, which gives me 5 over x minus 1. So we keep going, the limit as x approaches 1. Combine my terms there, I'm going to get x squared minus 1 over x minus 1. And you can see if I put 1 in, I'm still going to get 0 over 0. So almost there, almost there. This one here, factors of negative 1, that get me to 0 because I have no middle term. So this is going to be x plus 1, x minus 1, all over x minus 1. My x minus 1's cancel out. And I'm left with the limit as x approaches 1 of 1 plus 1, which is 2. So f prime at 1 is equal to 2. You can't leave your answer just 2. I have to identify what you're doing. So this is f prime of 1 is equal to 2. Anyways, my derivative evaluated at 1 gives me 2. Okay, well, I think 26 minutes is definitely a long enough video. Yes, and this is where I was ending the first one. So good luck on watching this. A lot of examples, and there is lots to cover. So just keep chugging along there.